And here on the executive stage, welcome Fabrice Bernard from Theodo and his host, Flavien Hautbois. You guys tell us all about Lean AI at Theodo. I'm very interested to hear about this. The stage is yours. Thank you.
Thank you, Roberto. Hi, I'm Flavien. I'm delighted to introduce our expert speaker today, Fabrice Bernard, someone I've known for almost 10 years now.
We cannot hear you, I think.
Really? Fabrice, can you hear me?
Yes, I can hear you.
Okay. Probably you do. Okay, probably on the Roberto's side then. So I've known you for almost 10 years now, Fabrice. Can you believe it? So Fabrice is the author of the Lean Tech Manifesto, and very recently a Shingo Prize recipient. So big congratulations to you, Fabrice, and to Benoit, his co-author and co-founder also. They are both co-founders of Theodo, an IT consulting and delivery firm, which is international and is present in France, the UK, and Morocco. So I had the pleasure of working at Theodo years ago, and we've also collaborated more recently. Having seen things from the inside, I can tell you that they walk the talk. They are serious about lean, they are serious about tech, and well, that's exactly why we are here today, is to explore how the lean tech model helps leaders and teams navigate the AI revolution. So not with the hype, but with concrete practices that scale. And I will hand things over to Fabrice in a moment. I'll be back at the end for short Q&A sessions. If you have questions along the way, please drop them in the chat or in the Q&A part of the Zoom workspace. And take a moment also to think in your industry, what questions would you challenge with Fabrice? What questions about AI would you like to address? So let's give a big round of virtual applause to Fabrice. And Fabrice, the floor is yours.
Thank you so much, Flavien. Thank you for the very kind introduction. Yes, so my goal today, and let me start sharing the slides, is to really share how we're navigating the AI revolution at Theodo from a leader's perspective. Marek has been very kind to share his experience around AI in software and now this morning. So if you've seen this talk, I'm going to try to take a bit of a bigger picture kind of angle to the problem. And if you haven't seen his talk, it's very good, so you can probably catch up later. I'm reusing actually to start the same slides as Marek, which is really, for people who are not in software engineering to try and understand what AI means. So there was a turning point in our industry because we were, everything was happening as usual. And then there's this technology that shows up and, that basically starts writing functions automatically. So you don't even have to think about the content. You barely have written the name of the function you want to write, and the AI just writes the whole content of the function. And you end up spending more time actually, doing like some typo corrections, like you can see here. But the really some of the hard work, which is writing the algorithms, writing the formulas, you're going to see it right now, can actually be sometimes fully written by AI. Here, ta-da! So you've got one function. And often, once you have one function, there's probably like the opposite functions you need to write or equivalent functions you need to write. And that's where AI will shine even better because it's able to kind of, using the context that it has, like start doing the rest of the job. So here's an example of, a quite technical task that, gets done in 2 minutes, thanks to AI basically writing all the complexity. And the software engineer just has to like think of what the intention, write the function name, and the rest is done by AI. So let me accelerate this. Up. Anyway, let's get to sorry. I hope the sharing is still working. Screen share is paused. Sorry about that. Okay. Hopefully it's working again. Oh. All right. So this example was really to show you that a task that would have taken 15 minutes for, I think, a good software engineer now takes 2 minutes. So it's a big disruption. And we're talking about our first discovery of AI. So we're talking about 2 years ago. And really the complexity of the kind of tasks that AI is now able to do in software engineering has really grown quite rapidly. And now we're talking about the kind of tasks that would take 2 hours for humans now that can be automated using AI. So it's a huge revolution. It's, everyone's wondering, what can I do with that? What does it mean for my business? And clearly, one of the key things that has been happening is people are thinking about using AI to do layoffs, to cut their headcounts, which I find really a really negative point of view on that. And I think it's very dangerous, because if you're thinking about how AI will reduce my workforce, you're probably not looking at the interesting enough problems. On top of that, it's a very negative point of view. So we can see that the young people coming out of university nowadays are quite anxious. And I think these messages are certainly to blame about that. So what is the alternative? Well, the alternative is to actually think about how can I, leverage AI to do something which is really augment humans to create more value. And what is very interesting is this has all happened approximately at the time we were finishing the book, and that's been a very good guiding frame for us into thinking about this revolution in a positive way, in a really value creation way. So just to give you a bit of background, because not everybody knows our book yet, the Lean Tech Manifesto is really is us trying to capture our learnings for the last 12 years, scaling Theodo from 2 people to 700 people, trying to maintain an agile culture. And basically, we found in lean thinking a key body of knowledge to scale the company and to scale it in a way that was true to this agile intention. And so we wrote it as a kind of extension of the Agile Manifesto. So here you can see how we reworded the Agile Manifesto and also reordered the Agile Manifesto to give us principles that make sense at scale and make sense in trying to get this kind of culture that we wanted to have. So a culture of autonomy on the ground and a culture of fast innovation. So another way to portray the Lean Tech Manifesto is basically to use the TPS house. We haven't really reinvented the TPS house, apart from a bit of tech at the bottom, but the rest is very much the TPS house applied to technological environments. And so typically use the TPS as a compass to navigate technological innovation. And so I'll show you what this means in practice. So let's start with number 1, value for the customer. I think when navigating the AI revolution in your organization, we need to think of a use case that's going to create value. And I think that's been super important for us, because our most senior software engineers have also always been the most doubtful and dubious about the value of AI. And for very good reasons. Like, there's so many ways where value for the customer, where if the example I show you is AI accelerating the writing of code, but a lot of times the bottleneck to creating more value for the customer is not writing code faster. And so the senior engineers who are doubtful about AI are rightly doubtful. And I don't want to alienate them by saying, no, we need to do AI, whatever it takes. However, if we find a place where there's true value in using AI, of course, we're going to embark a lot more people in that adventure. So trying to find a place where AI actually creates value. And this is not easy. A lot of leaders are actually struggling around that question. But one really interesting point I've found, it's a very, very recent article from the Harvard Business Review, is like, stop running so many AI pilots and AI experiments and try to focus on one, area where it makes a lot of sense for your organization and go deep, because this is where you're going to create a lot more value. This is very quick, but some of the ideas I have, I found, of course, there's a lot of use cases where you can use AI to do augmented search, what is often called RAG in the industry. One idea that I don't find so widespread, but I think is very interesting, is AI digital twins of downstream teams. So typically, if you have a compliance team, or if you have like a controlling team, instead of waiting 1-2 weeks to send them something, you wait for their approval, you wait for their feedback, and then you iterate a few times because what you did was wrong. Actually have a digital twin of them that allows you to have instant feedback. So basically shift left quality, create basically an unknown system much earlier, and then reduce the amount of iterations you might actually do with that end team. And also everything around translation in a very large sense. In our case, because we've been on the Gemba a lot of times, we realize, okay, there's not that many cases where writing code faster makes sense in terms of value, but there's actually one case where it makes sense, and this is modernization of legacy systems. So this is really the area we decide to invest in and build a center of excellence, a center of AI excellence around AI-powered IT modernization. And so this is a big example of how you start that kind of center of excellence. We built a big obeya to engage everyone in our R&D with a goal, which is to reduce monetization costs by 3x using AI. And so that was step one. Step two if you look at the Lean Tech Manifesto, is tech-enabled network of teams. And this idea, which is probably the one that is like the most different from TPS, is that if you want to create the kind of team-based organization that you find in TPS or that you find in large-scale agile organizations, you need to make sure that you need to make the technology, the systems that you work with much more modular. And that's also something we found to be a very interesting guiding principle in addressing AI issues. Because I think one of the key ideas that people tend to underestimate sometimes is how much the accuracy of AI decreases fast with the size of the problem. So the bigger the problem you want to address, the much less accurate the AI is. And this is very much like reducing in an exponential manner. And that's very, very interesting, because a lot of people are trying to use AI in quite a naive way, throwing a big problem at it, and then thinking this is not working for me. Typically, in our case, if you told the AI, please, can you take this legacy system and modernize it for me, it will go in random directions. But I think the same way that if you try to 3D print a car, it wouldn't work, because there would be the system is too complex, and so there would be a few issues here and there, and altogether the compounded issues means that it would never work out. However, if you just decide to break down the problem and actually use technology on smaller parts and then assemble them together, then you can actually have amazing results. And so typically in modernizing legacy systems, what we realized is that we should first break down the systems. And actually here we again leverage AI to break down the systems into smaller components. And AI is very good for that, because you can really navigate systems in a bit of a more flexible way than any typical static analysis tool you could use. Of course, I'm talking about my industry, which is software engineering, but I'm quite sure that this idea is actually applicable to other places. How leveraging AI to like navigate the system and breaking down in components. And then once we have broken down the problem, our AI problem becomes modernizing small components into small modern components. So we've broken down the problem, and this is much more approachable, because all we have to write like what we call transpilation agents. So problems that are at the size of, I'd say, about 80,000 tokens, like basically under the 100,000 tokens area, knowing that that's an interesting, by the way, interesting kind of orders of magnitude to have in mind. The LLMs start becoming useless from 200,000 tokens on average. 200,000 tokens is about 20,000 lines of text. So typically in coding, 20,000 lines of text is not a lot. A big system is usually 1 million lines or many millions. And so here, and you can't just like, look at the line, you need to add a lot of instructions and add a lot of context. So when you want to stay under 100,000 tokens, you need to look at things that are usually under, I'd say, about a few thousand lines. But once you have broken down the problem and you're working on small components, then you start having very high accuracy. And that's very interesting. And now talking about accuracy and quality, the next pillar is right first time. And this is where we use a lot of lean ideas to actually get to a decent result. So first, Jidoka is one of the key ideas that we use all the time when we're talking about LLMs and AI. People have, of course, now almost everyone has AI experience by like chatting with ChatGPT. But that also means that most people have a very naive, I would say, an experience of AI, which is you ask AI to solve the problem and then it kind of works, 80%-ish, but then you still have to do work on top. What creates a lot of value for us is if we can scale these agents to hundreds of similar components. But this means that the agent needs to have very high accuracy on that component. And that means that we iterate on the agent until they work one shot or right first time for the whole category of examples that we're testing our agent on. And that requires, whereas you could get an 80% good result in 5-10 minutes, so really quickly, to get to this kind of 95-98% accuracy, that usually you have to work probably like a day and a half. It's quite tedious. It's a bit annoying. So that's why a lot of people don't make that investment. But this is where you actually end up with a much, much better quality and also a much better understanding and intuition of what works, what doesn't. And yeah, very much like Jidoka, until it works, you stop, you erase everything, you go back to the initial system, you improve the prompt, you try again. So very different from vibe coding, which is the term that is now used in our industry, where you chat with the AI. So you basically iterate on the output. And what we're saying is Jidoka, you should iterate on the input until you have a very, very accurate system. So first idea, Jidoka. Second idea is early detection of quality issues. You create value when you start, combining all these components together into a bigger system, but that's only going to work if the components that you combine together are really high quality. And this is when you need to detect that as early as possible. So once we start scaling our modernization, so typically here we have a Kanban of APIs to modernize, and we transpile the code. We're going to try Lean ID, Pokayoke, we're going to try to use technologies where a lot of bugs are just automatically detected. So typically typed languages easier frameworks to use. So typically the choice of technology, in our case, of the target technology will be very helpful in making sure that what we produce will work. And then, of course, a lot of testing here, automated testing, which is the equivalent of the and-on, because you want to make sure that as soon as you've produced a part, a new modernized component, you can check whether it works or it doesn't work. So that's, I would say, the equivalent of the and-on system. And then there is a final check for the moment. I mean, in our current strategy, this is all there to augment the software engineer. The software engineer can then check if they're happy with the result. If there's an issue and they need to iterate on the output, they can actually put that issue in the red bin. And, that's where it depends. But often, let's say, if they're in the scaling phase, you correct the thing, you put it in the red bin. And then this is where we arrive at the third big idea of fourth big idea of the lean tech system, which is the learning part, and typically Kaizen here has been very important. You know, looking at the red bin to improve the scaled factory and look at how we can actually improve the prompts, the agents, to make sure that we keep on having very high accuracy and we can continue scaling fast. So analyzing the code, analyzing and seeing how the prompt can improve them. And then, of course, upgrading the system accordingly. What is very interesting is that the results on that particular niche, I would say, use case, which is modernizing legacy systems, is that we've managed to accelerate modernization by a factor of 3x. So a project that was typically estimated at 70 weeks took only 21 weeks. A project that was estimated at 12 months took actually 4-ish months. So we are at a huge value creation here for our customers, which is really great, which also means that all the senior engineers at Theodo that were a bit doubtful of AI now have a proof that AI in certain cases is very useful, and that, you know, creates curiosity and creates better understanding of AI, which, you know, we can then leverage in other topics. One key important thing is to, I'm just adding this, but what is also very, when we say modernizing faster, we really mean higher quality output. And the higher quality output exists because we've done all the things I've talked about in terms of quality, which is Jidoka until the result is good. And of course, a lot of like testing to make sure that it's still good once we scale to like hundreds of similar components. So yes, so my conclusion to that, and then I'm very open to all your questions, is that I found lean tech to be, you know, lean to be an amazing compass when navigating a tech revolution. Of course, what I'm mentioning lean tech because I think it's lean in the world of technology, and AI is typically in the world of technology. And it's been great at, you know, finding the big problem that our organization can solve with AI. In our case, the big problem is that software has been eating the world. It's everywhere. It's in cars. It's in planes. It's in your house now. It's even in your, you know, in healthcare. But that was happening on top of crumbling legacy IT systems, which was starting to be very scary actually when like me, you were seeing the quality of the systems that our world was running on. And I find that very exciting that, you know, thanks to AI, we have an opportunity to address those systemic risks and rebuild healthy infrastructures. And I believe that in all organizations, in your organizations, there's probably a similar opportunity where AI can really improve things. And so instead of thinking always about AI in terms of how do I reduce my workforce, I want us all to think in terms of, you know, what is the big problem that we can solve with this new technology? And I think that's where lean is very shining. If you want to continue the kind of conversation, I am on LinkedIn, and so you can connect and follow me if you want. Thank you very much.
Thank you, Fabrice. So there's one question in the chat so far. I see that two people have raised their hands. I don't know why exactly, but for the people who've raised their hands, if you can ask the question on the chat, that would be great. Thank you. There's one question about the larger context windows of newer LLMs, which allow to use more code, more input, and probably have higher accuracy on the larger tasks. What do you think of this, Fabrice?
Of course, it's an amazing question. So Eric Schmidt said at the end of 2023 that, or was it end of 2024? Anyway, he said it like at least a year ago that the context window issue would be solved and that wouldn't be a problem anymore. And the reality is we're 1 year down the line, it's not solved at all. What is very interesting, and that's why I showed you the graph, whether there's a technical limitation, because most LLMs like really cut at 200,000 and Gemini does cut at 1 million, is not really the big issue. The big issue is the accuracy, and the accuracy goes down. And what is interesting is there's been so much improvements in LLMs in so many dimensions, but that one is not the one where we've seen the most improvement. It seems that there's like this exponential decrease of accuracy seems to be like quite a big, hard problem to solve. And so that's why when you think of how AI can help on a problem, the question number one is how can I break down the problem into smaller problems where AI will actually solve with high accuracy?
That's great.
Answers like Christophe's questions.
So have you had to the participants, have you had a chance to think of how can AI create more value in your industry? Who's got something to Marie-Jus is saying AI is using a lot of energy. How to leverage this problem? How do you, the energy problem? I know that you have a stance on this, Fabrice.
No, I mean there's a lot of like ideas on around that. First, it's interesting. You know, I was it was the CIO of Michelin, Yves, who's a big lean fan, a great lean author, by the way. He wrote 2 amazing books around lean and digital transformation. And he was saying that where they're using machine learning, typically on optimizing the heating of tires, they were saving so much energy compared to the energy usage of LLMs. You know, the order of magnitude was like 10 or 100x. So that, of course, using LLMs for useless tasks is a waste of resources. Using LLMs to create value, if there's enough value created, that makes sense. So that's answer number one. And answer number two is that if there's a space where AI has been progressing at super fast speed, it's energy consumption. If you look at, typically on my MacBook right now, I can now run GPT OSS quite easily. It's got the intelligence of ChatGPT o3 mini, so it's actually very, very good. And it's only using the energy of my small MacBook. It does the battery is drained a bit faster, but so I think we're going in a direction where quite quickly we'll be able to use small LLMs for small tasks that have very low energy usage, and that's going to work out quite well.
There's 2 interesting questions, Fabrice, if we have time in 2 minutes. There's a general question on AI. Isn't it like, from Adam, isn't it like having a very good hammer, but trying to find nails everywhere?
But I would say that's exactly that. And I think but this is where lean is a compass, because you have a new hammer, and it could be helpful, and you're trying to look for nails, and what you need is to make sure that you look for holes that are valuable. I'm not sure it's a hole, but anyway, like use cases of where this new hammer is very useful. But I do think that's we need to do both as an organization. Of course, we shouldn't always look at why the hammer is useful, but then there's a bit of R&D that we should be doing in parallel, of course, all the time. So I think
if you have a 30 seconds to answer the last question, Fabrice, it's a challenge. Do you have to do the modelization? Can you do it incrementally, or do you have to do like a big bang kind of thing when you have to re-architecture?
That's a hard problem, and it's very much an engineering and architecture problem. In our cases, we try as much as possible to do it incrementally, but this is a hard problem where AI is not very helpful. This is like where we need senior experienced engineers.
Too much variability, probably, no?
Every project is unique in that sense. Yeah.
Yes. All right. Thank you very much to everyone. Thank you, Fabrice.
Thank you.
We'll let
Thank you, guys.
Yes. I'll let you take
Thank
over.
you. Wonderful time management. I'm really impressed. Thank you, guys. Wonderful presentation. Thank you. Goodbye.
Goodbye.